Here is a casino game with a secret. Flip a fair coin until tails shows up. The pot starts at $2 and doubles for every heads along the way. One flip, $2. 5 heads first, 64. 20 heads, 2 million. Question: what is a fair ticket price for this game? Compute the expectation and mathematics answers: infinity. Any finite ticket is a bargain. Now be honest. Would you pay $20? Nobody does. And nobody is wrong to refuse. Somewhere between the arithmetic and your gut, one of the two is lying, and finding out which took mathematics 200 years. The game has a birth certificate. 1713. Nicolas Bernoulli mails the puzzle to the mathematician Montmort as a curiosity about a fair coin gone wrong. For 25 years, it circulates as a private riddle among Europe's probability pioneers. Then his cousin Daniel publishes the resolution in the Journal of the Cent. Petersburg Academy, 1738, and the city's name sticks to the paradox forever. That paper did more than solve a puzzle. It introduced utility, the idea that money's worth is personal, curved, and measurable. Economics still runs on it. Watch the infinity assemble itself. Half the games end at once and pay 2. Contribution $1. A quarter pay 4, again $1. An eighth pay 8, $1 more. Every halving of probability is exactly canceled by a doubling of prize. 1 + 1 + 1 forever. The series does not converge. It marches. Expected value, infinite, and the proof fits on a napkin. Now play. For real. 1,000 games, average payout about $14. 1,000,000 games, still under 30 and the median never moves, $2. The infinite mean is real, but it climbs only when a freak jackpot lands, jumping the average in one spike, then starving for hundreds of thousands of rounds. A 20-head streak arrives once in 1,000,000 games. The mean is infinite. The experience is not. Keep this curve in mind, the spikes and the crawl. Every resolution we meet from here on is an attempt to price this exact picture honestly. Daniel Bernoulli, 1738, offered the cure. Money's value is not linear. The second million changes your life less than the first million did. Measure wealth in logarithms. Every doubling feels like the same step up, and recompute the game. The utility series now converges. The log average of the payout is exactly 2 doublings. 2 to the power 2, $4. That is the felt value of infinity. Bernoulli's curve deserves a closer look. Plot wealth against how it feels, utility, and the line bends, concave. Each extra dollar lifts you a little less. From that bend, one inequality falls out, Jensen's. The average of the curve sits below the curve of the average. A gamble is worth less than its expected value. That gap has a price tag, and an entire industry lives inside it. You pay an insurer more than your expected loss. The insurer, rich enough to be nearly linear, pockets the difference, and both sides are rational. The bend in one curve runs the world's risk markets. The logarithm is not a mood, it is survival. Imagine reinvesting your whole bankroll in favorable bets, over and over. Bet everything each time, one loss erases you. Bet nothing, you never grow. The fraction that maximizes long-run growth is the one that maximizes the logarithm, and betting beyond it grows your average wealth while bankrupting your actual one. Averages are seduced by jackpots. Logarithms live in the world where you go broke. Modern portfolio theory, position sizing, even how much of your savings belongs in one stock, all descend from this one correction to the mean. There is also a plainer question. What does a typical game actually pay? Read the distribution as a staircase of guarantees. Every game pays at least $2. Half pay 4 or more. A quarter 8 or more. Only one game in 500 clears 1,000. So if you price the ticket at $8, 3 games out of 4 lose money on the spot. The median game pays 2. The typical evening of play hovers near 4, exactly where the logarithm pointed. Expectation prices the fantasy. Quantos price the Tuesday night. One more twist from William Feller. The fair price depends on how long you play. Buy-in tickets, and the jackpots you can expect to meet grow with n. So the value of each ticket grows too, like the logarithm of n itself. 10 games, a fair ticket is about $3. 1,000, 10. A million, 20. Watch the real cumulative winnings track that logarithmic price line. The paradox dissolves into a schedule. There is no one fair price. There is a fair price per lifetime. Before we leave utility, one everyday paradox. The same person often buys a lottery ticket and an insurance policy in the same week. Both have negative expected value. The lottery keeps roughly half the stake. The insurer keeps the premium gap. By Bernoulli's curve, both purchases look irrational. Friedman and Savage proposed the fix in 1948. The utility curve is not concave everywhere. Near your current wealth it bends down, you insure. But a jackpot would move you to a different life, and toward that leap the curve bends up, you gamble. One wiggle in one curve explains a casino and an insurance office on the same street. There is a second cure, more brutal. No bank is infinite. Suppose the casino can pay at most about $1 billion, 30 doublings. Then the tower of one stops at 30. Expected value, $31. Not infinity. Against every dollar on Earth, 38 doublings, still only 39. The paradox needs a counterparty that cannot exist. Infinity was never in the game. It was in the fine print we forgot to read. One doubling game, 3 verdicts. The mean says infinity. A million real games say under 30 and crawling. The logarithm says 4. Expected value is a fine servant and a terrible master. It weighs jackpots you will never live to see. When infinity shows up in your arithmetic, check what it costs to actually meet it. The mean is infinite. The experience is $4.